Okay. So before enter into the today's class, let us see what we studied in the previous class. The last class we started with the data flow modeling. We seen the examples are half adder, then one full adder we seen, then the full adder using two half adder. But one more thing what we did in the previous class, we introduced the new concept, that is net declaration, or we can say wire declaration. So what is it meant by the net declaration? The net declaration is nothing but the signal will be transferred from the logic gate or the one logic module to the another logic module. That is what you can say. The wire signal or the net signal cannot be stored, or it won't store here actually. If there is any change in the input here A, B, then immediately the effect will be in the net also. That is why it's just it is nothing but a simple wire. You think about it in that way. The wire will be used to connect from one point to the another point. That is what this. So wherever you are getting like this, so you have to use as a wire. What is the need of this actually? So here, as I said earlier, if you are having the number of input variables is more, say example are like 32 or 64 input variables, then if your Boolean expression is very large enough, then it is very, very difficult to write the coding in the data flow modeling. What will happen when you write? So it will become as one single line also you can write, but so based on the parentheses, you may get the wrong answer. You won't get the prescribed answer, or we can say what is the expected answer you won't get normally. So to troubleshoot that Boolean expression, it will be a little bit difficult where exactly the mistake was there. So to avoid that, we can say one simple way, or to break, you want to break the Boolean expression with the help of the wire. That is why you see the full adder using two half adder be shown like this. So in this way, you can do. That is with the help of wire. The wire is a data type. Later we will study. The wire is a data type actually. You might have studied in your C languages, data types in C, right? Even same like this, even here also we are having data types in Verilog. The net is a one of the data type actually. So now, next what we'll do, we'll go for the second today's class, the continuation of the previous. As I given in the previous class, some little bit small work I given. Like you try to write the data flow model for full subtractor. I hope everyone is written, but once again what I will do, I post the question in the Google Classroom. You write the answers and scan and upload in your Google Classroom. So as I said earlier, you maintain one Verilog HDL notebook separately. Please don't write in any other papers. So then only we'll have a track. Okay, let us see today's actually. So what we'll do today, let us take an example of multiplexer. Let us take. The next is multiplexer I will take, or I will take as decoder. Decoder 2 to 4. So now, what is memory decoder actually? Already you might have studied. The decoder is nothing but it will give you the inputs are n to 2 to the power n outputs. That is the decoder. Now you can see this is a decoder. What is a decoder actually? From this figure, just we say it has n inputs and the 2 to the power n outputs. But this enable signal will be an optional one. So even if you want, you can use enable, else we can leave the enable also. So here, this is the diagram. Here we are showing the decoder 2 to 4 decoder, then followed by the truth table, then the given expression, that is the Boolean expression is given. So now what you will do, what is the Boolean expression for the decoder? Two input, that is A0, A1 is the input, then outputs are D3, D2, D1, D0. This is the output. So when 0, 0 applied, the input 0, 0, the D0 will be selected. D0 will be high. When 0, 1 is the input, then D1 is high. When 1, 0, when I apply, then D2 will be high. Then both the inputs are high, then D3 will be high. See this, totally we have 4 expressions will be there. So now what we need to do, for this we have to write the coding. See here, from this figure, I will write the coding for this. So here you think about, is there any Wire, so because I'm going to concentrate on little bit wire concept here. Is there any wire here? We see there is a NOT gate here. The NOT gate output is connected to the AND gate. So I can say this is the one wire. Yes, see, this is the one wire. Then where is another wire? Here. One more wire is here. Is there any more wire here? I think that's all. We don't have any more wire. Now what I will do, this is A0. So what I will do, this will you can consider as A0 bar. So here for this, what I will do, I will consider something called as S1 I will take. This I will consider as S2. Two signal I2. Now let us go for the programming. So let us start the program here. Yes. Okay, fine. So now let us write the program Verilog code. Let us write the Verilog code. Okay, first module followed by decoder. So decoder 2 to 4. Just given like this. Decoder 2 to 4. What is the input here? A0. Right? A0, comma A1, then outputs are D3, D2, D1, D0. This is the outputs. Then now next inputs are A0, comma A1. Next, what is the output? Outputs are D3, D2, D1, D0. You may think why I have written D3, D2, D1, D0, because just here I am specifying like this. Even you can write D0, D1, D2, D3 also, but later I will tell why I written like this. So now output is over. What about next? Actually, the declaration of wire is there. Yes, wire declaration is there. So what I will do now? Let us declare the wire. So wire. What is the wire is? S1, S2. This is the wire. Next, what you will do? We have to go for the one. Next, let us go for the program. So here, assign. First, what I will do? Let us consider the wire actually. Assign S1 is equal to, see this S1. What is S1 actually? It is a not of, correct? Not of A0. Next, assign S2, correct? S2 equal to not of A1. So two wires are now be written. So it is over. What next we'll do? We'll go for this set. This set is over now. Let us write for next. So what I will do? I will go for like this. A assign. Yes. First output is what? D3 I will write. Or you can write D0, D1. Even like this also you can write. It's not an issue. So D0. D0 is equal to, what is D0 actually? D0 is nothing but S1, S2, right? So S1 and S2. Next, assign D1 is equal to, what is D1 now output? You can see this. What is D1 output? D1 is nothing but, which is connected. One is A0. Another one is S2 is connected. A0 and S2. A0 and S2. Next, assign D2 is equal to, what is D2? See, one is A1, the another one is S1. A1, S1. A1 and S1. Next, assign D3 is equal to, what is D3? One is A1, another one is A0. A1 and A0. A0. Next, finally, end module. You see here, this Boolean expression, as you know, the D0 is high here, right? The D0 is high in the sense, the corresponding, the Boolean expression we have tried, A1 bar, A0 bar. Next is D1 is high, so it will be A1 bar, A0. Then D2 is high, then what is input is A1, A0 bar. Then D3 is high, it is nothing but A1, A0. That is what the expression is written here. See, I hope you write that. It may be little bit blur for you. So just note down from this, because already you studied in logic design, those things and all. Just I want to show how the program should be written. This is something but decoder 2 to 4. Same the way you have to write even multiplex next decoder, that is 3 to 8 also, like this only you have to write. Same the way now what I will do, let me write a multiplexer. Okay, now what is the multiplexer? In generally what I can do, multiplexer is nothing but how many inputs normally? It is 2 to the power n inputs. Next n selection lines and single output. Single output. This is nothing but your multiplexer. So now here I am showing the basic multiplexer. Instead of 2:1, just I will show 4:1 multiplexer. Here the 4:1 multiplexer, the 4 inputs, 2 selection line, then single output. Then how about will be a truth table for this? The truth table will be in this way. So inputs are, what is the inputs? Here we given the same values. So it is nothing but I3, I2, I1. So let me use in these inputs. So now input selection lines S2, sorry, S1, because 2 selection line, right? S1, S0, then outputs is Y. Y is the output. Now we'll see 0, 0, 0, yes, 0, 0, 0, 1, 0, 1, 1, 0, 1, 1. Since when it is 0, 0, it will select what? I0. When it is 0, 1, it will select I1. When it is 1, 0, it select I2. When it is 1, 1, it will select I3. This is the truth table for the multiplexer actually. See here, when 0, 0, the I0 will be selected. When 0, 1, then I1 will be selected. 1, 0, I2 will be selected. 1, 1, I3 will be selected. So here the input can be any number of bits. It is not a single bit also. It can be n number of bits based on how we are going to give the signals. Because normally we know multiplexing in the sense multiple channel, in that we need to select any one channel. Simple example, if you want to say the example for multiplexer is what I can say in a communication, or I can say example is, you can say TV actually. You know that the single cable is there. In the single cable actually multiple channels we are getting, but your selection line is nothing but your remote control. So from your remote control, whatever the number you can press, the corresponding channel only we can view in your TV. We cannot view any other channels. That is a simple example of multiplexer we can say. Now, how to write the Boolean expression for this? But you think it is little bit very difficult to develop the Boolean expression for 4:1 marks, because inputs are how many variables now? We'll see here totally 4 variables. Here 1, 2 variables, because even this also is input, even this also is input, plus 4 plus 2, totally 6 input variables. If totally 6 input variables, in the sense you think the inputs are 6, Correct, output is y only. So 6 combination, 2 to the power of 6, 64. So 64 combinations you have to write, then corresponding output y you have to write, then you have to put the 6 variable k map, then you have to get the Boolean expression. Instead of that, I will give you a shortcut idea how to write the Boolean expression for multiplexer, n number of multiplexer you can write. So first, let me give for 2:1 simple way, then it will be easy for you. So for mux 2 to 1, first mux 2 to 1, I will write how it will be expression. Okay, as you know, mux 2 to 1, what is the truth table? How it will be? Truth table, like I'll say input is 2, right? So simple, I'll say input is 2 input, 1 output. So I1, then I0, then output is Y. Or selection line, I'll say selection. This is selection, this is output is Y. Then you can see selection is 0, then output is I0. Then selection is 1, output is I1. Now you see, this is the simple truth table 2:1 mux. When yes selection, this is yes means selection, you can think, or I'll say cell selection line. This is your output actually, Y is out. When selection line is 0, select the I0. When selection line is 1, it select the I1. Now based on this, let me write the Boolean expression. Let me write. How can I write now? Y is equal to, okay. Now first what I'll do, which will be selected? I0 will be selected when I0 dot, I give, I0 will be selected when actually I0 selection line is equal to 0. That is the meaning of that. So what I will do, selection should be bar. I will write as like this. Selection bar, that is the meaning is 0. When it is 0, this I1 will be selected. So next plus I1 dot, when the I1 will be, this I1 will be selected, I1 will be selected when selection line is equal to 1. So selection line is equal to 1 in the sign, it is selection. See now, let you apply the value now. First, you see apply. If selection is equal to 0. Now you apply in the above expression test. Y is equal to what I'll get? I0 dot selection bar. Selection is equal to 0 means the bar it means 1 I'll get plus I1 dot selection is equal to 0. The what I'll get now? I0 dot 1 plus I1 dot 0. I will get as I0. See, Y is equal to I0 we got. Next same the way, if selection is equal to 1, if it is selection is equal to 1, now what will be output Y? Y is equal to I0 dot selection line is equal to 1 means selection bar, this is selection bar, so it will become as 0 plus I1 dot, it is 1. Now what I'll get here? I1 I'll get, see, exactly the same thing you need to apply for 4:1 multiplexer also. So let us write the Boolean expression for 4:1 multiplexer. I hope now you can try. So multiplexer expression 4:1. Let me write mux 4 to 1. Okay. So now you can try yourself. See this truth table and you can write Y is equal to, yes, first Y is equal to I0. When I get I0 actually, I0 dot, okay, when I get I0, S1 bar, S not bar, because 0, 0. 0, 0 means S1 bar, S not bar. So S1 bar dot S not bar. Still I am not written bar, so let me put a bar over there. S1 bar, S not bar. See, S1 bar, S not bar. Yes. Next, what I will do best instead of that, I will Yes. Okay, let me write. Y is equal to yes. Y is equal to yes. First, I0 dot yes. Now what is it? S1 bar, then S0 bar. Yes. Plus next I'll get I1. I will get I1 dot when I'll get S1 bar next S0 because it is 1. Next again plus next is I2 dot yes I2 when I'll get I2 S1 dot S not bar plus next I will get I3 when I'll get I3 will get S1 I S not I. See now I hope you might have understood that how we got the expression now. Let us check whether it is right or wrong. We need to check, correct? So first what I will do, if S1 is equal to 0 and S0 is equal to 0 because both are 0, right? Both are 0. I should get Y as what? I0 I should get. So let us apply over there. Y is equal to, apply now, I0 dot S1 bar, S0 bar. S1 bar, S1 both are bar. So 1 dot 1 plus. Next I1 dot, I hope you can try this. I1 dot S1 bar. S1 bar means 1 dot S0 means 0. Next plus I2 dot S1. S1 is 0 dot S0 bar is 1. Then plus I3 dot S1 S0 0 dot 0. Now you think now what I'll get? See, wherever the 0 is there, this term will get cancelled, this also cancel, this also cancel. Finally, I get what? I0 I'll get. See, this is the simplest way you can write the Boolean expression without using the KMAP or multiplexer. This is a shortcut method I'm giving. So same the way you can write for 8:1 mux also. Simple. What will happen? For 8:1 mux will come y equal to I0 into S1 bar, S0 bar, sorry, S2 bar, S1 bar, S0 bar. Why? Because 8:1 multiplexer will have 3 selection lines. Right? Because input is 8. So input is 8 in the sense the selection lines are 3. So S2, S1, S0. We can take like this. Then you have to write. I hope you understood this.